All right, hi everybody. Welcome back to 10600 Math Background for Machine Learning. This is the second lecture. If you're joining us for the first time, just a couple of reminders. Piazza is the central location for everything related to the course. In particular, we're going to keep the syllabus post on Piazza updated with everything you need to know. Of course, we highly recommend that you read all of our wonderful posts from the instructors on Piazza, but if you're in a hurry, the syllabus post should be a one-stop shop to get everything you need to know. Things that you need to know include lecture notes. We're going to hand those out at least a couple days before every class. We'll post them on Piazza and link them from the syllabus page. You're responsible for reading the lecture notes before you get to lecture. It includes assignments, so there are going to be some as we had on Monday, there's going to be some in-class exercises. There'll be exercises that are due before class every day. I wanted to point out and make sure that everybody knows that there's two in-class assignments that we had last class, plus one lecture note assignment that was due before the beginning of class today. There were a few hiccups with Replit, the site that we were using to do the assignments. I think those have all been ironed out, so please let us know if that's not the case, because obviously we don't want any stupid site problem to prevent you guys from getting at the assignment. Please post that on Piazza or text the TAs, and we'll try and get that fixed. In particular, we're going to be discussing the solutions to those assignments in this lecture. So I want to know if anybody's been prevented from submitting by technical problems, because obviously we'll delay discussing the solutions if people have been unable to submit. So post on Piazza or text the TAs. In general, if you have questions during lecture, your first recourse should be to post on Piazza. The TAs are watching Piazza and they'll try and answer where everybody can see it. If you need a little bit more interaction, please feel free to text the TAs. Their contact information is on the Resources tab of Piazza. You click Resources and then Staff, and you'll get everybody's office hours and contact information. Let's see. What else do we have? Oh, we've been posting some good stuff on Piazza about technical stuff for the course. So there's a nice Python tutorial that Marcus, one of our TAs, has posted there. There's also a ton of Python tutorial material. If you just hit Google, the web is full of it. It's one of the most popular languages today, so there's lots of resources for it. And of course, again, if you have questions, please feel free to ask us. Let's see. There were a couple of sort of administrative questions. So I think I have these on slides. So let's see if we can advance the slides. Okay. Oh yeah, so I already said the syllabus post, that's your source for everything. Everything related to the class. Python tutorial post, go have a look. Marcus put together a pretty cool one. People have asked about audit forms for the class, so if you just email me a partly filled out PDF, I can sign it and email it back to you. People asked how is the participation part of the course going to be graded. So if you look at the grading post on Piazza, it tells you what fraction of the course's grade is based on each one of the types of work you're going to be doing. And at the end it says 5% participation. We're going to be looking at people who are very helpful in, for example, answering questions from other students on Piazza, or people who are helpful to us in revising assignments, like discovering bugs in assignments and helping fix them, or just any of the other ways that you can be helpful to your fellow students. If we see you be helpful to fellow students or ask an insightful question or something like that, we'll make a note of it, and at the end of the course, at the end of the mini, we'll look at how many notes we have for each of you, and the participation grade is going to be based on that. Let's see, assignments so far. So I mentioned those at the beginning of the course. There's been some in-class assignments together with one that was due at the beginning of class today. And those are all related to the lecture notes on sets. So at this point in the course, you should have a pretty good feel for all of the sort of complicated things we want to be able to do with sets. And the most complicated one of these was set comprehensions, or set builder notation. Set comprehensions are the Python language equivalent of the mathematical notation that's called set builder notation. It's basically, you've probably seen a lot of it before, but it would look like something like this: x for x in the integers, and x is greater than or equal to 0, right? That's the sort of, that is the messiest close brace I've ever written. There we go. So that sort of set builder notation is going to be pretty common when we talk about, for example, data types or logical operations that we might want to do as part of a machine learning algorithm. So it's good to be fluent in it, and hopefully the exercises that we've done so far have given people an opportunity to become fluent. All right, TAs, could you make sure to post to me if anybody's been messaging you about problems submitting the assignments? And otherwise, in a couple of minutes, I'm going to start talking about those. All right. So in the sets notes so far, in addition to set builder notation, one of the important things that we looked at are tuples, right? So you've probably seen a lot of different notations for tuples. The one we're going to be using in this class is something like this, in angle brackets. 1, 2, 3 is a tuple with 3 elements, all of which are integers. You can have mixed type tuples, so 17, 3.14, and the string foo, right? That would be a valid tuple as well, obviously a different type than the first tuple, right? So this one is in the set R cubed, and this one is in the set, well, it's actually, I guess, maybe even more accurate to say that it's in the set Z cubed, right? It's also in the set R cubed, because that's a bigger set. This one is in the set Z cross R cross strings. There's not a standard single letter notation for the set of strings. So tuples are useful. As you see, we write times between the sets, right? Set product notation to say the set of all such tuples, right? So this notation here means the set of all tuples where the first element is an integer, the second element is a real, and the last element is a string. And that's a good way to build complicated sets out of simpler ones. All right, so all of that should be review. Now I'm going to start talking about the assignments. So people did pretty well on the assignments. There were a few problems that people had. With the only A to M assignments, by far the most common problem was people having trouble with regular expressions to test you were supposed to test strings for whether they were in the range, all characters in the range A to M. That's pretty straightforward to do if you're familiar with regular expressions, but apparently a lot of people needed to brush up on regular expressions. So, but after doing that, I think everybody, by and large, managed to submit a pretty good submission. Some of the common problems were failure to reject non-alphabetic characters, right? So the string was supposed to be composed only of letters A to M, and so you should also reject digits or hash signs or anything else like that. There were also some fence post errors, so people used, for example, range of A comma M. That's a fence post error because it will reject M. It should be range of A comma N. And so these are small errors. They're not gonna greatly affect anybody's grade on the exercise. With the not div exercise, that was mostly good. That didn't have any curveballs like regular expressions in it, so people had by and large no trouble with it. In both of those two, there were a few people who failed to use set comprehensions the way the directions said to do. So again, the point of the exercise was to teach you guys about set builder notation, and set comprehensions are sort of the closest thing to the mathematical set builder notation that you're going to find in a programming language. And there were some people who had, oh, so sorry, there's a question about whether students are supposed to do types and functions lecture notes before today. We asked people to read through that before class, but there were none of the exercises mentioned in that are due yet. We'll maybe do a couple of them today if we get to them. And if not, we'll assign them later. So the types and functions lecture notes are, you're responsible for having read through them by now, but you're not responsible for having done any of the exercises in them. Okay, so where was I? So one of the last problems that people had in the exercises was understanding the difference between lists and sets. So there were some people who accidentally returned a list, or who used a list comprehension and then typecast it to a set, which is unnecessary. You can just use a set comprehension in the first place. And there was one, I think, that coerced something from like a list to a set, back to a list, and back to a set, which is, again, unnecessary, but it doesn't keep you from passing the unit test, so it's okay. So that's the list of problems that I noticed when I was looking over people's solutions. If you had one of these problems and don't understand how to fix it, or if you had one of these problems, or if you had a different problem, please make sure to ask questions so that we can get you to understand how to fix that problem. So let's see. I think I can go ahead and show a solution to those two exercises. So let's go to a new page, and right. So for the not div question, right? So the set builder notation that we would want to do, we would have. Right, it was supposed to be x that is in some set S that you're told ahead of time, such that x mod 2 is, so we want it to be not divisible by any of them, so x mod 2 should not be, well, I'm writing in math right now, so I'm going to write the math not equals. And x mod 3 has to be not equal to 0, and x mod 5 has to be not equal to 0, and there should be an and in between there. Right? So that's the solution in set builder notation. Whoa, I certainly had, all right, let's try writing that again. writing and talking is apparently not good. There we go. X mod 3 not equal to 0 and X mod 5 is not equal to 0. Right? And so in Python, actually looks very similar. It is X for X in S if X mod 2 not equal to 0, right? So notice that Python uses the % character for mods, and it uses the word and for and. So X % 3 is not equal to 0, and right, the same thing, X mod 5 is not equal to 0. And again, have to use the Python notation, and remember to close the brace. All right, so that's the solution to not div. The solution to a to m is actually pretty similar, right? So it's let's see, X for X in S if a to m of X, right? Because we asked you to filter those out. And this here, that's the helper function. Let's see. So I'm getting questions from people who've just joined the course and who haven't done the assignments. It's going to be hard to give people credit for assignments since I'm going over the solutions right now, but the idea is that there should be lots of in-class exercises that you guys can do, and so if you do well on all of the other exercises, having missed this one won't hurt the grade of anybody who's just joining. So no. We're not gonna do these exercises in some makeup form for people who are joining, but it shouldn't hurt your grade. Just look at them, make sure you understand how to do them, because you'll need that knowledge for later on in the course. All right, and then so we were talking about the a to m helper function. There's a lot of different ways to write the a to m helper function. One of them is to use re.match, right? So that's the regular expression matching function. And you would give a regular expression, which in Python is r triple double quotes. And the one regular expression that you could say would be start of string, and then characters a to m and a to m, and then repeated, and then end of string, right? And then you end the triple double quotes, and then of course you have to give the string as well to the regular expression matcher. So this would be how to define that helper function. All right. I'm also getting asked about people who submitted code that doesn't pass all of the tests. We're going to try and take a look at code that doesn't pass all tests and possibly assign partial credit for it. We recommend that you submit code that passes all tests, of course, but if that's not an option, please submit the best you have, and we'll possibly, although not necessarily, assign partial credit for it. Again, for these exercises, they're supposed to be fairly, each individual one of these exercises is not supposed to take a huge amount of time from you unless there's something that you need to go and learn in order to do it. But once you know all of the necessary background material, these exercises should be fairly straightforward, and so we're going to grade them mostly on a yes or no basis. Partial credit for people who get really close. All right, so that's the two exercises from in class. We have a question as well about 25% assigned to lecture notes, readings, and video. Right, so we're going to have exercises for you to do in two different ways. There's going to be in-class exercises that are going to be basically like the not div or like the A to M. Those were originally going to be in class. We extended them because people were having trouble completing them in class, but we're still going to call them in-class exercises. And then there's exercises like the DB join that we assign in between class periods to be done by the beginning of the next class periods. Those are going to be related to the lecture notes that you guys are responsible for. And so those go with the lecture notes portion of your grade, right? So in class portion of your grade is activities we do in class. Lecture notes portion of the grade is activities that are assigned between classes to do with the lecture notes. Now, as it happens, both of the within both of those categories, we've only assigned so far short programming assignments on Replit. That's not going to be the case forever. We'll assign all sorts of stuff in both categories. And so just for each exercise, we'll try to be clear about whether it counts as in-class or lecture notes exercise. Okay, so people are requesting that I explain the helper function in A to M again. So I guess before I do that, I need a little bit more space around it. So I'll just write again here. This here is the helper function, which we're going to define down here. And so the full code is going to be to return re.match that, and we need the function definition above it. So it's going to be def A to M of str, right? So that is that's the full definition. And I guess there are a few different parts, right? So there's the function definition right here, right? This is the function definition. It actually has only one statement in the function body, which is to return a value. That value is gotten by the Python library function, re.match. So I guess in the sample code we had import re above that, and you had to keep that there. So re is the Python module that does regular expressions, and match, the match function tests whether a string has a match starting at the beginning of the string for a particular regular expression. And if you don't know regular expression syntax, I would highly advise reading up on it. It's a very useful thing to know just for general purposes, both in this course and in later wrangling of any data that's associated with a computer. But just as a quick parse of this particular regular expression, the caret here says that the start of the match has to start at the beginning of the string. The $ here says that the end of the match has to be at the end of the string. The part in square braces here, that says that it's a character class. So it says all of the characters between lowercase a and lowercase m, and all of the characters between uppercase a and uppercase m. And so this will match one character that's an acceptable character. And then the star here says repeat that 0 or more times. So this regular expression as a whole says that the whole string from beginning to end has to be 0 or more repetitions of the legal characters. And again, I would highly recommend reading up on regular expression syntax. There's sort of a common regular expression syntax that's used across multiple languages, including Python, Perl, the Unix shell, and well, I think there's a library for C++ as well. And so there's basically like, if you want to test strings for whether they have some particular property, regular expressions are often a really good way to go. All right, so those are the in-class exercises. Again, I say in-class in quotes because we extended them to give you guys more time to complete, but they count as in-class exercises. If anybody still has any questions, I would ask that you try and ask them on, if you can formulate them precisely, ask them on Piazza, otherwise attend somebody's office hours and see if you can get a better understanding of what's going on. All right, so next, there was the dbjoin function. And that was the function that we requested, that we assigned as a check on your reading of the lecture notes, in particular the set product and set builder notation. So this was based on the lecture notes that were titled, I think, setslecturenotes.pdf, posted on the syllabus post in Piazza. And part 9 of those is the long form description of this, and then Replit has the Python environment for you to be able to submit together with a briefer description. So just as a reminder, we're doing a database operation. So you can think of a table in a database as an element of some set of the form x cross y cross z cross ... right? So if there are 10 fields in the database table, then there'll be 10 components in that expression. So for example, a good example of a table would be in SIO, you guys have student records, and those student records include the student ID, the program that you're in, the year that you are in the program, and so you could write that the rows of that table as tuples of the form student cross program cross year, cross all of those other things, but let's say for now that there's only those 3 things, right? And so an example would be, the student could be a string like JQ Bovik. The program could be something like Master of Science in Computer Vision, and the year could be, I don't know, let's say you're a junior. That's represented by 3 in the registrar's database, right? So that would be a typical entry, right? So this is an element of that set. Oh, and I'm sorry, this is not really the best notation. The actual tuple, we would prefer to use the notation angle brackets, like that, with no crosses. You can also write it the other way, but it's more conventional to do it this way. All right, so those are the tuples, and what we're trying to do is do a set builder notation on tuples. In particular, as it says in the problem statement, what we would like is all tuples of the form x, y, and z, where x, y is in the first table, and y, z is in the second table, right? So hopefully everybody understands this set builder notation right now, right? We have an expression here that says what are the elements of the set, and then we have conditions on the variables that appear in this expression, right? So here the tuple xy has to be in the first database table, which we're calling A, and then the tuple yz has to be in the second database table, which we're calling B. All right, so to translate that to Python set comprehensions, again, it looks kind of like this. It's not exactly the same, but it looks like this. we can say, sorry, let me bring, got to make sure that I have my correct solution up to copy from. I don't want to give you an incorrect one. So we can have something that is, right, so in Python, tuples are with parentheses, so it'll be x, y, z, for x, y, so that is weird. I apologize for the for x, y in A, for, and this is going to be the difference here. We're going to say for A, comma, z in B, and then we're going to say if y equals A. Right? And so the reason we have to do this, when you tell Python for x, y, and A, it will iterate over all x, y pairs that are in the set A. If you tell it for a, z, and b, it will iterate for all a, z pairs in B, and then you can test y and a to be equal. If you wrote for y, z, and b, Python would actually bind y twice, once for here and once for here. One of the bindings would shadow the other one, and it wouldn't be possible to test for equality. So that's a slightly confusing thing. A few people got tripped up by that in the assignments. I have some notes here on what problems people had with this assignment. The main problem that people had was occasionally, again, people failed to use set comprehensions, and people did some unnecessary coercions. But the most frequent confusion was the error that I mentioned below, right? So we can't say y here because of the rules about scoping in Python. So again, please ask questions if you had trouble with this and if you don't understand the solution. There's another, you could also write it some other ways, right? So another good way that people wrote it, and this was the way that I wrote it the first time that I did it, would be something that looks like this. So we'll have a tuple, and I'll say how we'll fill it in later, but we'll say for little a in big A, for little b in big B, right? And so here A refers to an entire tuple that's in the A set, and B refers to an entire tuple that's in the B set, and we'll again filter by saying that the second element of A of 1, has to be equal to the first element of B, which is B of 0. Right? And then once we have that, we'll have A of 0. Here we can put either A of 1 or B of 0, so let's put B of 0 and B of 1. Right? And so what this is doing is, so here Python will let you bind two variables at once, so that's kind of a clever thing about Python. Here we're binding one variable to the entire tuple. Here we're binding separate variables to the first and second elements of the tuple. And so the notation's a little bit different, but these two are solving the problem in exactly the same way. All right, so those are the problems that people had. Let's now switch to talking about the types and functions lecture notes. So We posted these on Monday. Hopefully everybody's had a chance to read them. So I don't want to go over them in unnecessary detail. I just want to make sure that if people have questions that are not addressed, we go over those questions in lecture here. So we talked about in the notes data types, right? So you see data types in a lot of languages like int or float. Those are actually just names for sets. And so we've been talking a lot about sets. We can describe data types as just the set of values that they are, right? So the int data type contains all integers you can represent in, let's say, 32-bit floating, 32-bit non-floating point. Point has to be at the very end of it for it to be an integer, right? And then languages provide ways for combining the data types, and those are exactly like the ways for combining sets. So you can do set union, you can do tuples, which are called records or structs or something like that in different languages. And maybe one of the most interesting things, and something that people might not be familiar with because it's not in every language, there are data types of functions, right? So in particular, let's get a fresh page. So in particular, we can write something like R to R, right? That's the type, that's the data type of functions that map a real number to another real number. And so you can define a function like that, right? So in C, you might say, you know, float, you know, foo of float x, brace, return, I don't know, x plus 2.0, right? And then close the brace, right? So that would be a C function that is of type R maps to R. Now, C forces you to give a name, right? I had to come up with a... oh, okay, so people are asking me to go back and talk about tagged unions. So hold the thought about functions, and we'll go back and talk about tagged unions. So in C, C is a very, you know, enough rope to hang yourself sort of language. It does not enforce that you have to know whether a particular value is supposed to be interpreted as an integer or as a floating point number, right? So in particular in C, everything's just bits. And so floating point numbers are one way to interpret a bunch of bits, and integers are another way to interpret a bunch of bits. So if you take the union of those two data types, there are actually values that can be interpreted either as an int or as a float. I'm being told to increase my writing size. I will do that. There are sets of bits that can be interpreted either as an integer or as a floating point number. And so in C, when you define a union type, you take the union of two sets. Those sets are not disjoint. And so you have to know when you access the thing whether you wanted to interpret it as an integer or as a floating point number. That causes confusion. It's also the source of a great deal of power in C. C loves to you know, take integers, you know, take crazy data types and interpret them as bit strings, and then like mask those bit strings against, you know, do crazy logical operations on the bits of those strings, right? That's like, you know, a tool that for C programmers you'll have to pry it from their cold dead hands. When you talk about strongly typed languages, right, the strongly typed languages, people throw up their hands in horror when they look at C's unions, and they say, okay, whenever you define a union type, it should be a disjoint union. You should make sure that every element of one type is not an element of the other type that you're doing a union with, and so that means that when you come back and look at an element of this new set, of this union type, you know immediately what it's supposed to be interpreted as. And a lot of languages will do that, for example, by, if you have a 32-bit word, you'll take the first 3 bits of that word, and you'll have, you know, 8 possible values of those first 3 bits, and you'll use those 8 values to to indicate what the type is of the variable. So you might have 000 means that it's an integer, and 001 means that it's a floating point number. And then, of course, you strip off those bits before you try and interpret the remainder of it as a floating point number. If you want to do that in math notation, so again, that's like, you know, the C way of thinking of it, right? It's like bit masks on your floating point numbers. But if you want to do that in math notation, you do it the way that's described in the lecture note. You just attach a tag to each element, right? So we had tagged unions, and they looked like you know, Z cross 1 union, sorry, not U, but union, R cross 2, right? And so elements of this set might include something that looks like, you know, 173, that's an integer, comma 1, right? Everything has to have 1 as the second element of the tuple. And elements of this other one might look like 3.14, comma 2. And everything there has to have 2 as the second element, right? Because if you take the cross product with a singleton set, all you're doing is you're putting a 2 on the end of every element, right? And so this is part of that one. This is part of that one. And either one of them is part, right? So we'll call this type T, right? So this is an element of T, and that is an element of T. And if you look at those elements of T, you know whether they're reals or integers, right? And so in particular, you know, even if you say that, you know, 1 equals 1.0, right? Even if you said that was true, you'd be able to tell whether you were originally interpreting it as an integer or a real, because you tagged it with a 1 for integer or with a 2 for real, right? So that's tagged unions. We'll put that over there. Okay, so going back now to here, right? So C forced us to name that function. And there's not really any reason, right? Foo is not a particularly descriptive name. There are a lot of languages that will allow you to have a what's called an anonymous function. This is a function without a name, right? And so, you know, math notation, that's pretty common, right? You know, x squared, right? That's just a function where we give you the expression and we didn't assign a name to the expression. People will sometimes say, you know, p of x is equal to x squared, but you don't have to do that, right? You can just have the function named x squared. And so the mathematical version of when we want to be very clear about the arguments to an anonymous function, we'll use what's called lambda notation. Okay. People are confused about the last part of tagged unions. I'm not sure what the confusion is. Maybe somebody, one of the TAs can maybe text me. Until then, I'll go on about so people are not sure about this notation, I think, is the problem, right? So this is the cross product between two sets, right? One of them is Z, and one of them is just the singleton set that contains the integer 1, right? And so Z is all integers. This is the singleton set containing 1. Elements of this product set, right? They're tuples, where the first element is an integer, and the second element is an element of that set, right? Which is to say that it has to be 1, right? So Z cross the set 1 is just all tuples of the form integer comma 1, right? And same thing for R cross 2, it's all tuples of the form a real number comma 2, right? And so the 1 and the 2 function as tags, and so when we take the union of those two sets to get the tagged union T, the integers and the reals don't mix. They stay completely separate. Hopefully that clears up what notation I was using. All right, So the math notation for an anonymous function is what's called lambda notation. So we'll say something like the Greek character lambda will have an argument to the function, x, and the type of that argument, let's say real, and then another argument to the function y, and the type of that argument, again real, and then a period, and then the expression. So it could be, you know, x squared minus 3xy, right? And so that is an example of a lambda notation for the function x squared minus 3xy, and it's being very clear that the arguments are supposed to be reals, right? And so the type of this thing, right, that thing up there is an element of the set r times r to r, right? It's a function that takes it takes a tuple of two real arguments, and it returns a real number. And the fact that it returns a real number is not actually marked anywhere here, but we can infer it from the expression here, because if you square a real number, it stays a real number, and so forth. And so there are a lot of programming languages that implement anonymous functions. So Python is one of them, Lisp is another one, and the lecture notes have the syntax for that. The key thing, I guess, is just that, as you can see, you can build some fairly complicated types, right? So if you have you can imagine, you know, one function taking another function as an argument, and you could have, you know, that function as an argument has to take a tuple of, you know, 2 reals and 3 integers as its own argument, right? And so you can get really complicated type expressions. And the reason I'm pointing this out is that later on in this course, and definitely later on in other machine learning courses, you're going to run into objects that are of fairly complicated types. One example, you don't have to worry about what these are right now, but when you get to reproducing kernel Hilbert spaces, these are what make support vector machines tick, if you've heard of support vector machines. When you get to those, you're going to be worrying about types where you know, things can be interpreted. Basically, you know, you nest when you describe the type of an object, it'll be a nested expression that's fairly complicated to parse. And so it makes sense to make sure that you have the ability to you know, really intuitively understand these data type expressions in order to not be confused by that while you're trying to learn about some complicated algorithm. So I put together some exercises on Replit to let you guys practice with some data types, especially function data types in anonymous functions. So let's see if I can go ahead and enable those. And so the first one is called +1. It's a fairly simple one. It's published now, and I will post the link to it on the Piazza website. All right, so that's posted to Piazza. You guys should all be able to grab it. And the description of the exercise is, I'm going to put that up as well so that everybody can see it. But it's in the lecture notes that I sent before. So. Here's the description. That looks like that's very small text, so let's make it bigger. There you go. All right, so it's the first exercise up here. We're just going to try and write a function that takes another function as input. The input function should be of type r to r. In other words, the input function should take a real input and compute a real output. And then our function is going to take that function and just add 1 to it. So it's going to make another function that computes f of x plus 1 and return that function. And so you're going to need to use lambda notation in order to do that. And the lambda notation is described in the lecture notes right up there. Right, so this is an example of Python code for a lambda. And let's see what people are how people are doing on that exercise. So it looks like a few people have already submitted. That's great. Let's take a look at some of these submissions. Yep. Yeah, so some people are definitely getting it. If not, please ask questions to the TAs, and if there are common questions, they'll have me talk about them in class. So everything looks great so far. A bunch of people have submitted the right answer. But I'm going to wait a bit because, well, a fairly small fraction of the class has submitted anything. So we'll wait for people who who aren't already quite as familiar with lambda expressions to complete. So a bunch of people have completed the exercise. A lot of people as well haven't. I'd say probably still only less than half of the class has completed it, so don't worry if you haven't. But I wanted to make sure that the people who've completed it don't get bored. So I've released another exercise on Replit. This one's called Filter. You should be able to reload and see that exercise. And that exercise is the one just below in the lecture notes, and the instructions are given there. I'll talk a little bit more about what you're supposed to do there in a bit, but I wanted to make sure that anybody who's finished the first exercise has something to work on. Okay, so some people have expressed confusion about what the meaning of the parameter to +1 is. So I'm going to switch back to the whiteboard. Right, so the code template that you have is something like def +1 of f. And Python doesn't let you restrict the type of the input, but I am promising that in the test cases that will be of type a function that takes a real and maps to another real, right? So what that means is that somewhere inside the body you could say something like f of 3.14, right? And that would return a real number, right? We don't know which real number, but somewhere inside the body you can just call f, this argument f, you can just call it like a function, right? That's what it means to pass a function as an argument. That function is a variable, and you don't know what it is ahead of time, but you can use it just like an ordinary function anywhere in the body of your function. And maybe it would help if I publish, if I show you guys a test case. So I'll take a look at that. All right, so here is a test case for the +1, right? So to explain this test case, right, I'm computing a function f right here. That function is just the absolute value function. I'm calling +1 with f as an argument. So g is now another function. That's the one that you have to compute inside +1. And then I'm testing to make sure that that's the right function by saying, well, g of 3 should be the absolute value of 3 plus 1, which is 4. G of -2 should be absolute 2 plus 1, which is 3, and so forth. So if you see that test case, hopefully that helps you understand what it is that +1 has to do. All right, so people are doing really well on the +1 assignment. That's great. I haven't seen yet any submission that is incorrect, which is really good. Congratulations, guys. Since it's getting to be 10 minutes before the end of the class, I'm not going to make the other one an in-class exercise. Instead, I'll convert it to a lecture notes exercise and make it due at the beginning of class next time around. A reminder, next time around is not Monday because Monday is Labor Day, but Wednesday. So it's a week from today at 1:30 that one's going to be due. I haven't edited the due date yet, but I will do that. I have already edited the due date of the first one to make it due half an hour after the end of class in case you guys want to keep working on it for a little bit. It shouldn't take longer than that. Let's see. So I wanted to say a little bit about the second exercise so that we can maybe answer questions about it while we still have TAs handy. So here is the second exercise, which is this one starting here. Write a Python anonymous function that represents this predicate, right? So we take some function of x and compare it to a threshold. So by predicate, I mean it returns true or false, which is what it should do if you do a comparison. And then also write a set comprehension called filter that takes a set, like a set of numbers, and a predicate, like this one above, and it goes through and filters the set for all of the elements for which the predicate evaluates to true. So if you give it a set, if your predicate tested whether something was even and your set was 1, 2, 3, 4, 5, it would return 2 and 4, a set containing 2 and 4. And so that's the that's the exercise. It's just a little bit more complicated. It uses both set comprehensions and anonymous functions, so you guys should be comfortable with both by now. And we're going to make it a lecture notes exercise that is due at the beginning of next class. So the other thing I wanted to point out, the function that you're writing in plus 1, what is the type of that function, right? So I want everybody to think a little bit about what the type of that function is, and then I will say the answer, right? You don't have to, this is not an exercise we're going to check, except you guys can check yourselves internally. And so, think a bit, and before the end of class, I'll tell you what the answer is. Maybe write it down for yourself on a piece of paper so that you can compare. All right, so before class ends, let me just briefly answer the question that I posed. So the question was, what is the type of that +1 function that we described, right? So the answer is, well, okay, so it takes in a function that maps a real number to a real number, right? Oops, that is, so that's got to be part of the type. That's the type of its arguments. It is itself a function, right? So that function symbol has to be part of the type. And then what does it return? It returns another function, which is also a function from reals to reals. So compare that answer against what you wrote down for yourself. And if you didn't get it, or if you don't see why this is the right answer, please make sure to ask us questions, either in class or in office hours. And like I said, I have extended the +1 function to be due half an hour after the end of class. And we're going to extend the other one, the filter exercise, to be a lecture notes exercise. So it's not due until beginning of class on a week from today, Wednesday. So I hope everybody learned a bunch from class today, and we'll see you next time. Thanks a lot. I'm going to stop the stream now and go ahead and extend that exercise.